Now that we have discussed the same base theorem for triangles and the same base theorem for parallelograms, now here comes even the applications which have been discussed further. Now comes the concept of combining a triangle and a parallelogram. Now let's investigate what if there is a triangle and a parallelogram with the same base and between the same parallels. How do we connect a parallelogram and a triangle is how we're going to discuss in the session. Same base theorem for triangle and parallelogram. Connecting triangle and parallelogram. Same base theorem. So let's see how we can connect a triangle and a parallelogram with the same base theorem. So here, let's see how we can understand the triangle and a parallelogram in the same base initially before we understand the theorem connecting them. So for a triangle and parallelogram on the same base and between same parallels is understood as the common base AB and the parallel line L which is parallel to this. And say I have a triangle out here, and next I have a parallelogram out here. ABC is the triangle and AB DE is a parallelogram. So here I have a parallelogram. So ABC is a triangle and ABDE is a parallelogram. So they are of course found to be on the same base and between the same parallels L and AB. Triangle ABC and parallelogram ABDE are on the same base AB, as can be seen here, and between the same parallels L and AB. That is the line L which is parallel to AB. Is how we understand a triangle and a parallelogram on the same base and between same parallels. Now comes the question on the investigation of the areas of the triangle ABC and the parallelogram ABDE. Will the areas be equal, or is there any relation which connects area of triangle with area of parallelogram is the biggest question. Let's investigate area connected with parallelogram and triangle on the same base and between same parallels. Now let's state the theorem. Same base theorem for a triangle and a parallelogram. So statement, triangle and a parallelogram on the same base and between same parallels. If the triangle and a parallelogram are on the same base and between same parallels, makes the area of parallelogram to be twice that of the triangle. So in such a case, we see that area of parallelogram is twice that of area of triangle. It is not equal, but area of parallelogram is twice or double of the area of triangle. So the statement is very clear with its statement which says a triangle and a parallelogram on the same base and between same parallels make the area of parallelogram to be twice that of the area of triangle. Is how we understand the connection between a triangle and a parallelogram when they are on the same base and between same parallels. Let's see the property in brief. Suppose I have a same base AB and I have a line L which is parallel to AB. Now I have a triangle I have a parallelogram. So here is the parallelogram AB DE. So I have a triangle and a parallelogram between the same parallels and the same base. So here is the parallelogram. And here is the triangle. Is how we understand a triangle and a parallelogram on the same base AB and between the parallels L and AB. So the statement clearly says that for triangle ABC and for parallelogram ABDE, which are on the same base and between same parallels, area of parallelogram ABDE is twice of area of triangle ABC. That's how we understand the property of area of triangle and parallelogram. Why do you think is the area of parallelogram twice of area of triangle? How is the twice of the triangle connected? It's very simple, because a parallelogram is a four-sided figure obtained when its diagonal divides the parallelogram into two triangles. Say for example, I join the diagonal BE. So here I observe that there are two triangles between the diagonal, and we know that the two triangles are congruent in case of the parallelogram. A diagonal makes the two triangles to be congruent in a parallelogram is what we have learnt in the previous sessions. So if I have a diagonal, it makes area of this to be equal, or the diagonal bisects the diagonal of the parallelogram, divides the parallelogram into two equal areas. Is what we have learnt in the previous session. And therefore, when I cut the diagonal BE, I get two triangles ABE and BDE in the parallelogram ABDE, whose areas are equal. Therefore, this area equals this implies this would be twice of the added areas. And therefore, when I add this area with this, exactly two triangles on the same base are equal. So area of this equals area of this equals area of this. So A equals A plus A, which is 2A. So area of triangle equals twice. Area of parallelogram is twice of area of triangle, is how we get when each of the areas are equal. So therefore, this could be with the possible area of triangle ABC, which is equal to area of triangle ABE, which is equal to area of triangle BDE. All three areas being equal is how we get the three areas equal in this. And therefore, area of parallelogram ABDE is twice area of ABE, because the diagonal makes the two triangles congruent in a parallelogram. These two areas divided by the diagonal are equal, which is nothing but 2 times of area of ABE, which is equal to ABC. Therefore, area of parallelogram ABDE is equal to twice area of triangle ABC. That is, area of parallelogram ABDE is double or twice of area of triangle ABC. Therefore, we come to the conclusion that if there is a triangle and a parallelogram on the same base and between same parallels, which make, there must be with the condition that area of parallelogram makes exactly twice the area of the triangle, is how we understand the property connecting the triangle and the parallelogram in the same base theorem. Triangle connected with parallelogram to the same base theorem.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.